All right, welcome. Today we're taking a journey somewhere truly wild. Not to outer space, but deep into the very fabric of information itself. We're going to tackle one of the most mind-bending ideas in all of tech, the quantum internet. So, let's just kick things off with a pretty wild thought. What if information could, well, teleport? I mean, seriously, what if you could send a message from point A to point B instantly without it actually crossing the space in between? And get this, what if the very act of sending that message automatically made it impossible to hack? That sounds like pure science fiction, right? But that is the core promise of the quantum internet, and it's a future that scientists all over the world are actually building, piece by tiny piece, as we speak. So, to really get our heads around this, we're going to break it down. First up, what is this thing? Then we'll look at the weird physics that makes it all tick. After that, how does it actually send a message? We'll also dig into why everyone calls it unhackable. And finally, how close are we to actually building this new web? Okay, let's dive right into it. The first thing you've got to understand is that the quantum internet isn't just a souped-up, faster version of what we use today. No way. It is a completely different beast altogether. So, the internet you're on right now, it sends information using bits, ones and zeros, as little pulses of light or electricity. But the quantum internet, it plays by a totally different set of rules, the frankly bizarre rules of quantum mechanics. It uses single particles, like individual bits of light, to carry information in a fundamentally new way. So, what are these strange new rules? To really get the quantum internet, we have to learn the language it speaks. And it all begins with a totally revolutionary idea that throws the classic bit right out the window. Meet the qubits, or quantum bits. Now, a regular bit, the kind in your phone, is like a light switch. It's either on or it's off. That's it. A qubit, though, is more like a spinning coin. While it's spinning in the air, is it heads or tails? Well, it's kind of both at the same time. This incredible ability to be in multiple states at once is called superposition, and it's what lets a single qubit hold so much more information than a plain old bit. Now, what's really interesting about this slide is just how different these two are. On one side, you have this simple switch. It's the foundation of literally all modern computing. But on the other, you've got this spinning coin, the qubit. Its power to be everything at once is the secret sauce. But there's one more rule we need, and this one's a doozy. And this is it, quantum entanglement. Einstein himself called it spooky action at a distance, and for good reason. Imagine you have two of those spinning coins, and they're linked in this spooky way. The instant one of them lands on heads, you know instantly that the other one, even if it's on the other side of the galaxy, has just landed on tails. It's this instantaneous, spooky connection that makes secure communication possible. So, we've got our building blocks, this idea of superposition and the spooky link of entanglement. Let's move on and see how this all builds into an actual communication system. How do you actually use this stuff to send a message? Well, the whole process is less like sending an email and more like creating a super secret handshake. First, you create a pair of entangled particles. You hold onto one and you send the other one over to your friend. Now, here's the brilliant part. If any spy tries to peek at that particle while it's in transit, the very act of observing it changes it. It messes it up. So once the particle arrives, you and your friend can check to see if it was disturbed. If it's untouched, boom. You use the linked states of your particles to generate a perfectly secret one-time use key. You can then use that key to encrypt any message you want over the regular internet, knowing for a fact that no one else could possibly have it. And that security aspect isn't just a nice little feature. It's really the single most powerful use for the early quantum internet. What it promises is nothing short of a truly unhackable future. This is the absolute core of it. You simply can't spy on a quantum message without getting caught, because looking at it forces the qubit to pick a side, and that leaves behind a big flashing sign that says, "I was here." So the crucial point is this. Privacy isn't based on some complex math problem that a future supercomputer could crack. Nope. Privacy is baked right into the laws of physics. So why does this all matter? Well, just imagine a world with completely secure banking, where financial fraud on a large scale just is impossible anymore. Or think about military and government communications that literally can't be intercepted, or health records that are truly fundamentally private. That is the revolution we're talking about.
This all sounds incredible, I know, but it's not just a bunch of ideas on a whiteboard. Right now, researchers are actively building the very first pieces of this new web.
And this brilliantly illustrates the journey we're on. Just a few short years ago, this stuff was totally confined to labs, but now we're already seeing the first quantum links being set up between cities. The big goal is to have a global network start taking shape within the next decade. It's a huge challenge, for sure, but the progress is real, and it's happening fast. So the real takeaway here is that we are witnessing the very, very beginning of a new age for the internet. The ultimate vision is a global network where these strange, powerful rules of the quantum world are no longer just a scientific curiosity, but are the absolute bedrock of how we protect and share our most important information. And that leaves us with one last, pretty profound question to think about. A world with perfect, unbreakable security it changes everything, from global politics to our own personal privacy. So what will we do as a society when our secrets can truly be kept forever?